Section 2-7 is about solving proportions. You probably already know how to do this, so I'm not going to take and make a long video on this one. I'm going to make it short and sweet. So proportion states two ratios are equal. So you can have A over B equals C over D. Those are two fractions that are equal. You can also read that as A is to B as C is to D. Sometimes in our end of the year statewide testing, they'll word it in that configuration. A is to B as C is to D. So with these equal proportions, equal fractions, you can look at it as equivalent fractions. So if you have 2/3 equals A over 12, 3 times 4 gives you 12. So 4 times 2 has to give you A. So we know A equals 8. So we can just convert 2/3 to 8/12, and we will be equal to each other. So if you have 3/8 equals 30 over B, well, I know 3 times 10 gives me 30. And if I multiply the numerator by 10, I have to multiply the denominator by 10. So B then would be 80. So if you can treat them like equivalent fractions, that's great. But if I have 2/3 equals x over 17, I don't know what 3 times what number would give me 17. So when it's in that type of a problem, I have to use cross products or cross multiplication. And it says if A over B equals C over D, so again you start with your equal fractions, then A times D equals B times C. So you multiply on the diagonal, A times B equals B times C. So if I go back to this 2/3 equals x over 17, 2 times 17 would equal 3 times x. So then I'd have 34 equals 3x, divide by the 3, and I get 34/3 equals x. Most of the time they want you to leave it as that fraction, so you would not have to simplify down or do mixed numbers. The harder type of problems that they could have in this section would be where you don't just have a simple number, you have a variable and a number over your denominator. But again, you can just cross multiply. So 3 times this whole number, which is A minus 2, so you have to put it in parentheses, equals 2 times the 9. And that's this diagonal. So then we would distribute 3 times A, 3 times the negative 2 to get 3A minus 6. 2 times 9 is 18. And then we just solve like normal. Again, you want to leave the variable term alone. Opposite of subtraction is addition, so I'd add 6 to both sides. And that cancels my 6, and I'd have 3A equals 24. Divide both sides by 3 because the opposite of multiplication is division, and I get A equals 8. The other way we could look at this was with our equivalent fractions. So if I look 3 times 3 gives me 9. So if I multiply the numerator by 3, this numerator has to equal each other. So I can go the A minus 2 has to equal 6 because that's what 2 times 3 was. And then add your 2 to both sides and get your A equals 8. The reason I showed you this long version first is sometimes you can end up with a binomial, 2 terms, on the top and bottom, and so the only way you could do it is by cross multiplication. But if there is only one binomial, 2 terms, in the numerator or the denominator and it only happens once in the equation, then you could use equivalent fractions like down here. And those are your 2 examples. So now you may start your homework.